In Chapter 8, we're going to look at exponents, and eventually we'll get into some functions that involve exponents. But in the first few sections, we're just become familiar with properties of exponents and how to simplify expressions using these properties. So Section 8.1 looks at exponent properties involving products. Okay, so there's two properties that you need to become familiar with here in the first section. The first one's called the product of powers. In other words, when you multiply two things that have the same base, okay, then you can combine their exponents by simply adding them. So again, if you're multiplying two things with the same base, you can combine them by simply adding their exponents. In the second situation, if you're raising a power to a power, okay, so the way we would read this expression here, we would say that's a to the m to the nth power. In other words, you're raising a to the m and then you raise it again to the nth. Okay, so if you have that situation where you have a power to a power, the way that you can combine them is to multiply them together. So I know that when you have variables like this, it can make it kind of hard to see these properties. So hopefully as we run through some examples here from your notes, that'll start to make a little bit more sense. Okay, so in example number 1, part A, this is x to the third times x to the first. And since I'm multiplying two things with the same base, I can combine their exponents by just adding them. 3 plus 1, that's x to the fourth power. Okay. In part B, this is a power to a power. And so that tells me the way I combine those exponents is by multiplying. X to the 3 times 2, and we all know 3 times 2 is 6. Part C, order of operations still applies, so we're going to do what's inside the parentheses first. Okay, so I have a to the fourth times a to the third. They have the same base, so I can combine them by adding the exponents. So that's a to the 4 plus 3, and then the 2 still stays on the outside. So I simplify this down a little bit more. That's a to the 7th raised to the 2nd. And now we're right back to where now we have a power to a power, and so we can combine those exponents now by multiplying. So that's a to the 7 times 2, which is a to the 14th. Okay. Okay, part G, you will not distribute this 6 to both things inside because you are subtracting. If you are multiplying inside the parentheses, then you can distribute your exponent, but if you're adding or subtracting, you cannot distribute your exponent. Okay? And so the only thing you can do in G is recognize that this is a power to a power. And so now you can say v minus 8 raised to the 6 times 3. That's v minus 8 raised to the 18th power. 6 times 3 is 18. And you'd stop there. Nothing else you can do. In part H, you look at this and you say, okay, I look inside, I have b to the 4th plus b to the 3rd. I can't do anything there, okay, because b to the 4th and b to the 3rd are not the same power, so I can't add those two things together. The only thing I can do in part H is distribute the b. And when I do this, this is b to the 1st times b to the 4th, so that's b to the 4 plus 1 plus b to the 3 plus 1. Well, you know what 4 plus 1 is. That's b to the 5th plus b to the 4th, and that's where you stop. Okay? All right. Part I. Okay, part I, you'll notice here when you multiply three things, it doesn't matter what order you do them in. So you'll notice here the only things that have the same base are the m to the 5th and the m to the 8th. So those are the only things I can actually combine. Okay, I can't do anything with the a. So the a to the 2nd is going to stay out in front, and then what you have is m, and now I'm multiplying m to the 5th times m to the 8th. So that tells me to add my exponents. So the simplified answer here would be a to the 2nd, m to the 13th. And that would be it. Okay. In part J, scroll back up here, part J. So again, exponents first, right? PEMDAS, order of operations, do inside the parentheses first. Well, clearly there's nothing I can do here. It's a -2 and a -2. I can't do anything. So the second thing I do is the exponent. So I have -2. Now I have -2 to the 3rd. Understand what that means. That means -2 times -2 times -2. Okay? Well, negative 2 and negative 2 makes positive 4. Positive 4 times negative 2 makes a negative 8. So negative 2 to the third power is really negative 8. And so now all you're doing is negative 2 times negative 8. Well, a negative and a negative makes a positive. 2 times 8 is positive 16. Okay? As we take a look here at example K, or part K, I should say, example 1, part K, you'll notice here now you can distribute this 2 to everything inside simply because inside the parentheses you are multiplying. You're not adding or subtracting. So you got to take that 2 to everything. So what you have here is you have negative 4 to the second, r to the second, s to the 3 times 2, right? Because you're going power to a power. And so now you just simplify. Negative 4 squared. That's negative 4 times negative 4, which is 16. R to the second is done. And then s to the 3 times 2 is s to the 6th power. And that's your simplified version. And finally, in part L here, all you're going to do is add your exponents. So you have w to the 2 plus 7 plus 6 plus 3. That's w, let's see here, that's 9, 15, 18. Done. Okay. All right. In example 2, let me scroll back up here. It says simplify the expression, no calculator. Same idea. Okay, except now it's a little bit more extensive in some cases. So first of all, notice here, since I'm multiplying inside the parentheses, I can distribute. So what you have is 3 to the 4th, y to the 4th times y to the 5th. I can simplify 3 to the 4th. That's 3 times 3, so I'm going to do this on the side here. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th is 81. And now what you have here is you have two things with the same base. You have y to the 4th, y to the 5th. I can combine those, and remember the way that you combine them is you add your exponents. So it's 81 y to the 9th power. I'm going to leave part B for you to do. That's just like part L that we did up above, so that shouldn't be too hard. And then part C, again, you should be able to do that on your own as well. Just go ahead and distribute that exponent and then simplify. All right, so I'm going to go ahead and let you guys mess with the rest of these. Okay, these are all similar to what we did on the front side of your notes there. So go ahead and simplify part B through F. And then bring those to class. If you have any issues with them, then we'll make sure that we talk about them. Okay, and then finally, example 3, it says find the missing exponent. So we're just kind of applying this a little bit. So understand what you have to recognize here is since I'm multiplying, I would take this exponent and that exponent and add them. Okay, so in other words, 6 plus the question mark would have to equal 12. Well, that makes the question mark 6, right? Would be the missing exponent. In part B, it's a power to a power, so you'd multiply those. So in other words, 4 times the question mark has to equal 12. Well, 4 times what equals 12? The question mark has to be 3. And then finally in part C, okay, again, you can kind of work this out. So I know that I would distribute this 3 to both guys inside. Okay, so I know I'd have 3 to the 3rd, which is 27, and then I'd have z to the 3 times question mark. Okay, and that whole thing would have to equal 27 z to the 18. Whoops. Z to the 18th power. Okay, so this is 27, so that takes care of that. So now you have z to the 3 times question mark equals z to the 18th. Well, 3 times what equals 18? 3 times 6. All right, so that sums up our notes here for section 8.1, exponent properties involving products. As always, if you have any questions, make sure you bring them to class and get them answered.